Hello everyone, I'm Lee. In this video, we're going to look into operator overloading. So let's first look at the student class. This is a class we're familiar with, and we provide two constructors. One is a constructor that takes in the initial ID and GPA. If you don't give the initial ID or GPA, it will be set to this preset value. And another constructor is called the copy constructor and the destructor, because in the object we have a dynamically allocated memory. So constructor and the destructor, they're essential here. And we have two getter function, the accessor function, and the two mutator function. And for the accessor function, we make them constant function because they won't modify the internal state of the objects. And now let's focus on the operator overloading part. Something new here. The first one is this function. So this function's name is operator assignment. And it will take in a student object and it will return the student object by reference here. So the assignment operator overloading just means we want to teach this operator how to behave when the operands are student objects. So let's first take a look at the usage of this assignment operator overloading. So let's take a look at this one. We have two student objects, S1, S2. Then this is the assignment operator. If we don't overload the assignment operator, this line still compiles, but it will just do a member by member copy, which means in the student header file, let's see, member by member, one member is a pointer to the ID, so you just copy the pointer instead of copy the real ID. So you create a shallow copy there. Shallow copy could be a problem because now if we don't overload it, when shallow copy is created later on, when S1's lifetime is over, the destructor get invoked, so the ID got deallocated, and then S2's first S2, then S1's destructor get invoked, and it tries to deallocate that same memory again, the program will crash. So that's a shallow copy problem. And here, let's see, this assignment statement is equivalent to this one. So you invoke operator assignment, this function, on S2 and pass in S1 as a parameter. So you can view this one as a shorthand notation for this function invocation. So that means as long as we put our deep copy logic in operator assignment function in the student class, we will be fine. So that's what we're going to do. Let's take a look at student.cpp about this assignment operator overloading here. So let's see, you pass in a student object, and the first thing it does is to check if this is a self-assignment. Self-assignment, that means you want to assign yourself with yourself. Okay, let's see, how do we check self-assignment? We check address here, we check identity. So this contains the address of the current object, and address of a student gets the address of this passing object. So if those two are not equal, that means it's not self-assignment. If they're equal for self-assignment, you don't do anything because there's nothing to do. It's self-assignment. You just return the student object, the current student object. And how do you get to that? That dereference this pointer. Okay, and if it's not self-assignment, we first check, do you have an existing ID? If you do, I should deallocate that memory. Then I'm going to allocate big enough just for the pass-in student ID and do the string copy. So those ones are trivial, we're familiar with. You see, testing for self-assignment is extremely important, assuming if we don't do this testing, we come to this code. If it's a self-assignment, you go ahead and deallocate the ID, you just destroy yourself. After you deallocate the ID, of course ID contain no pointer, and so you just empty out yourself. So that won't be disastrous. So it's important when overloading assignment operator, you first do self-assignment checking first, and then deallocate the existing memory before you allocate the new memory. So that's assignment operator overloading. And now let's take a look at the other ones. We have another one. Let's take a look at this one. Operator equality, testing for equality here. When testing for equality, we have two choices. You can make this one a member function or a non-member function. Either one's fine. But here, for demo purpose, I make it a non-member function to show you how a non-member function works. So the operator equality takes in two student object and return either true or false. So this operator equality isn't part of the student class. You don't even have to put it in this header file. It could be somewhere else. It's just a global function that's not associated with student. So that provides some flexibility. So sometimes people prefer to overload the operator as a non-member function when they can do that. But for assignment operator, you don't have that option. It has to be member function because it's going to modify the left operand. When you assign one student object to another student object, you're going to change the left operand. But for this one, it could be member function, could be a global function, but you can only do it once. You cannot do both. The compiler won't like it if you do both. Alright, so let's take a look at how we use this equality operator in the driver. So we use it just like this, just like built-in data type, but what's really going on is like this. Operator equality takes in S1 and S2 as two parameters. That's what's really going on behind the scene, just like what's really going on here. But you see the difference here. Operator equality is a global function, not a member function of student class. See the difference here. So, and now let's take a look at the implementation of this equality operator overloading. And first of all, it's not a member function, so you don't do student : here. So it's just a global function which takes into a student object. And when you have a global function, a non-member function, you need to realize you lose that privilege of accessing private data directly. That means you cannot do s1.id. You have to go through the public interface, which is s1.getID, s1.getID. So that's the implementation for this equality operator. Now the last one we're going to look at is this insertion operator. The insertion operator, you see, I make it a friend for this class. A friend function of this class means it's not a member function of student class, but it has a privilege of accessing private data directly. That's what a friend for. Alright, you see, for this one, it can either be a friend function or just a normal function like this one. The reason we want to make it a friend is we want to provide that privilege of accessing private data directly. It cannot be a member function either because the two operands. So the two operands, the first one isn't even student class, isn't even a student object, so it couldn't possibly be a member function because the first operand is an OStream object. So when we declare a friend, we declare it inside the class. We say, hey, this function is a friend function of this class. We put friend keyword here. But when we implement this function, let's take a look at the implementation. We don't put friend there. So the friend declaration is in the class. And when we implement it, let's see the difference here. So we just go ahead, display the ID followed by the GPA. You see here, we don't do s.getID, s.getGPA because we're friends. We can access the internal data, the private data of S directly. So that's the difference here. And let's come back to this function prototype. You declare it as a friend of this class, and you see this is a function name. The first operand is an OStream object, and the second one is a student object. Let's take a look at how we invoke it. We invoke it just like normal, like a built-in data type. And what's behind the scene looks like this. Operator, insertion operator, take in two objects here. And you see the reason we return OStream object is we could change this one. You see, after we do this, and we still want to insert an end of line, so this one has to return an OStream object so that I can keep on inserting some other items on this OStream, this output stream. Alright, so that's about operator overloading. Let's come back, and in summary, we overload three operators: the assignment operator, which has to be a member function, and the insertion operator, which could either be a global function or a friend function for this class, and another global function, a non-member function, the equality one. So you can view operator overloading as for the programmer to teach the operator how to behave when the operand are object of this class. That's about operator overloading. Thank you.